Good afternoon, Year 7. Last week we were exploring how to visually represent a method or program in the flowchart form. We specifically learned what shapes are used to represent different events and words, such as a circle for the start and end terminator, parallelograms or slanted squares as input and output boxes, and regular squares where processing occurs, such as calculations. I'm going to keep these here on the slides to the side as a reminder for the rest of the lesson, just in case you need to look at them again when we look at further diagrams. I will re-say that. So our learning intention for today is familiarizing ourselves with if statements, both the function of them as well as how we can demonstrate them visually in a flowchart. Our success criteria for today is creating 3 different example flowcharts of programs that use if statements, including else-if ladders and nested statements, which we will learn about today. What is an if statement? Today we are going to look at another shape and form of processing called an if statement. And an if statement is a checkpoint where we see if something is correct or not. In code, it looks something like this. So if we have A equal 10 and B equals 20, and the question we're asking is A the same value as B? And if it is, we say yes, else we print no. It splits our flowchart into 2 pathways. One if the statement is true, and a different direction if the statement is false or incorrect. Let's imagine we are creating a machine to tell us what the temperature feels like outside. If below 23 degrees Celsius is cold and anything else is warm, we can say, if the temperature is less than 23, send us to the output to tell us that it's cold. Otherwise, or else, as we say in programming terms, output that it is warm. Then stop running the program. This is what you can see on the image to the left. But what if we wanted to be more specific and have multiple temperature feelings? We could group small ranges of temperatures into categories and give them descriptions like cold, chilly, perfect, warm, hot. For this, we would need to decide what numbers we would group together. For this group, the cold group, I have said that below 14 degrees Celsius is cold. So if we look at the number line, all of the numbers from 14 are cold. Note that because we are using the less than sign, the number 14 itself is not included, because 14 is not less than 14. If we wanted to include 14, because 14 is still quite cold, does anyone have an idea of what we can use? Yeah. Yes, we could put an is it equal to 14 in another if statement, or, to save us a bit of time, we can combine the less than and the equal symbol into a less than or equal to. So that now crosses off all the numbers below 14, including 14 itself. So the program will now check what the temperature is and check if the temperature is below 14 degrees. The temperature today, if I check with Google, is 24 degrees. So the program says no, it is not 14 degrees Celsius. If we stop there, all we know is that it isn't cold. We want to be more specific. Let's ask further if it is cool today or 21 degrees and below. Because the numbers below 15 are already ruled out, the program is checking if it is 15 degrees, 16, all the way up to 21. We can call this else if, because we know we have more questions ahead, but we are still asking if something is true or not. Sometimes people and programming languages shorten else if into just elif, just to confuse everybody. It's great. So this is what our program flowchart looks like right now, with our if statement followed by an else if, where the temperature is not within the first checkpoint. If it was, you can see that the program would tell us it was cold or cool in the second else if. So can somebody tell me what the flowchart would look like if we start including the perfect temperature category, if 25 degrees Celsius is the lowest number in the warm category? Pause for where this activity and enrichment and differentiation would occur. So this is our answer. So when we look at this flowchart, a pattern is starting to form that looks like it takes the shape of a ladder, sideways in this case, with the arrows downwards being the rungs and the steps. This is what we can describe as a ladder-structured if statement when shown in a flowchart. Also note that in a flowchart, instead of saying the rest, or else the numbers above 28, the diagram goes straight into the output symbol. If we were writing this out in code, however, we would call it else because there are no more ifs, just everything else. Now, let's look at nested if statements, or if statements within another if statement. Note that this is different to a ladder structure flowchart because instead of the yes moving to an output that then finishes the program, a yes keeps the program going to check more features within those categories. You can see in code how the if statements are stacked diagonally under one another, rather than directly below like in previous examples. I've got an example here where we're trying to find my dream skateboard. Here are my criteria for my dream skateboard in the nested if statements. A no means the rest of the statements in that line are skipped over because they're no longer relevant and we have our answer already. The rest of the class would be activities around this concept, catering to further differentiation.